It's the year 1920. A stranger walks through the streets of Kinshasa in the Democratic Republic of Congo. He's astonished how his city has developed. Many laborers moved here from surrounding villages. Although it seemed like a normal day for him, he will change the history of humankind forever. The stranger was preparing for work. He worked as a butcher for a local market. But this isn't your typical butcher. He is processing bushmeat. At some point on this day, he was injured and got a deep cut. He probably didn't know about the significance of this cut. But through this injury, he was the first person to be ever infected with HIV. HIV has become a global epidemic starting in the 1980s. To this date, over 36 million people have died of AIDS. But where does HIV come from and how did it evolve? My name is Gwen Steineck and today we'll talk about the origins and the evolution of HIV. Just as a disclaimer, this is the fourth part of our HIV video series. We already talked about possible HIV vaccines, how 2 people were cured, and how many more might be cured in the future. So with that, let's start. HIV, or the human deficiency virus, infects humans and causes AIDS. It is estimated that over 36 million people have died of AIDS so far and that over 38 million are infected right now. And this epidemic started in the 20th century. There are several theories when HIV first infected humans, but we know one thing: HIV is older than you might think. HIV-1, the dominant form of HIV today, was probably formed in the 1920s in Kinshasa. In this region, the simian immunodeficiency virus, or SIV, can be found in apes. Since this virus is very similar to HIV, it is very likely that it was transmitted from an ape to a human. This phenomenon is called zoonosis, and it means that a virus can jump from one species to another. This actually didn't happen once, but scientists now know that it happened at least 12 different times, but only one time the dominant form of HIV was created. Unfortunately, Kinshasa was the perfect breeding ground for HIV at the time. The city expanded and more people lived close together. Kinshasa also had comparatively many prostitutes, as a lot of workers moved there at the time. Moreover, unsterilized needles were used in health clinics, making the transmission of HIV even easier. Over the next years, HIV started to spread to other countries. In the 1930s, a series of newborn babies died from mysterious infections in Germany. The peculiar thing was that all the newborn babies seemed to be healthy, but they had a defective immune system. Today we believe that they might have contracted HIV due to unsterilized needles in the hospital. In 1969, a 16-year-old African-American boy died from Kaposi sarcoma. Kaposi sarcoma is a form of cancer which is rare and is often caused by HIV infections. In 1976, a Norwegian sailor, his wife and his daughter died of unusual infections. This family also had a defective immune system. And then in the 1970s, more and more drug addicts started to die in the United States. Then HIV infiltrated gay communities in large US cities. In 1981, unusual clusters of pneumonia were reported in 5 homosexual men in Los Angeles. These men have all been infected by a fungus called Pneumocystis jirovecii. This fungus doesn't normally infect lungs, but caused serious complications. And now scientists started to see the pattern. Seemingly everywhere, people died from infections with bacteria, viruses or fungi which are normally not harmful for us. But no one really knew why these people got sick. Most of them seemed to be healthy until their infection. It was only that at a certain point their immune system didn't work properly anymore. And with that the race started. Scientists tried to find out what caused AIDS. There was one major clue. Some people contracted this mysterious disease after receiving blood transfusions. You see, blood is normally passed through filters before it is used for transfusions. The filter helps to get rid of fungi and bacteria, but viruses are too small to be filtered out. So scientists started to hypothesize that a virus caused AIDS. In early 1983, French researchers isolated a virus from a patient who suffered from AIDS. They were not entirely sure what this meant, but they proposed that the virus might have to do something with the disease. In 1984, an independent team of researchers identified the same virus in AIDS patients, and 2 other research teams then did the same. A team of US researchers then summarized all of this data and found that this virus is always present in AIDS patients. In 1986, the isolated virus was named HIV, or the human immunodeficiency virus. Scientists successfully identified and named HIV, but it took much more work to find out how it precisely caused AIDS. When HIV enters the body, it circulates in the blood and starts to infect a special type of immune cell called CD4 positive T cell. If that happens, the body recognizes the infection and starts to fight the virus. In this stage, people often get symptoms for a short period of time. They develop fever or sweats. The fever vanishes after a couple of days, and for the next months the infected person doesn't know that anything is wrong. And this is one of the reasons why HIV remained undetected for so long. It takes years and often decades until the immune system is destroyed and AIDS fully develops. Once a cell has been infected, HIV releases its genetic information in the form of RNA. Then it uses a protein called reverse transcriptase to convert its RNA into DNA. The goal of HIV is to bring in its DNA into the host cell so that it can hide there. If that is successful, the virus often doesn't do much for a very long time, it just remains inside the DNA of the host. Slowly, however, HIV activates itself and makes new viral particles. The host cell finally bursts and the released HIV particles can infect new cells. This goes on for months and years. Slowly the patient loses more and more T cells and the immune system doesn't work properly anymore. Normally, fungi, viruses or bacteria which are not harmful for us suddenly become dangerous. They can infect AIDS patients and cause so-called opportunistic infections. These infections can then spread through the body, leading to the patient's death. And this has been recorded from very early on. AIDS patients die from unusual infections. But the years and years HIV can spend in the body of a patient also means that it has a lot of time to evolve. HIV primarily evolves through mutations. Mutations mean that the genetic information of an organism or virus is changed. There are two ways through which HIV can evolve and change its genetic sequence: replication or recombination. Let's first talk about replication. HIV is a so-called retrovirus, which means that it stores its genetic information in the form of RNA. As we've seen, HIV wants to incorporate its genetic information into the host cell, and therefore it has to convert its RNA into DNA. Each time the RNA of HIV is converted into DNA, there's a small chance that the produced sequence is slightly different from the previous sequence. Over time, these changes or mutations can accumulate, leading to new characteristics of the virus. Then HIV also uses recombination to become more diverse. This is also made by reverse transcriptase when it causes a process called template switching. When the same cell is infected by two different viruses, the reverse transcriptase can jump between both genetic sequences. By combining the genetic information of two different HIV viruses, we can have very drastic changes. We also know that this has been an important mechanism in the origins of HIV. Several HIV predecessors in monkeys exchanged genetic information which in the end gave them the ability to infect humans. And recombination even happens today. If we find two subtypes of HIV in a region, then 30% of all particles will contain genetic information from both subtypes. And both forms of mutations can make the virus drug resistant or deadlier. That's how HIV originated in a nutshell. Now I want to address some common HIV concerns, since there is apparently a big Wikipedia article about this. So let's start. Number 1. HIV doesn't exist. Yeah, apparently there's some people who claim that scientists have some big arguments whether HIV exists or it doesn't. And that's simply not true. Scientists normally love to argue. You can compare them to your family on a family trip. If there's conflicting data, then we have two hypotheses and then they argue back and forth until there's a common theory which makes everyone happy. But for HIV there is no evidence that it does not exist. On the other hand, thousands and thousands of researchers are working on HIV and they agree that it does exist. Number 2. HIV doesn't cause AIDS. There was a professor in Berkeley who famously said in 1987 that HIV doesn't cause AIDS. This guy had quite a lot of followers, and one of these followers actually took a needle, an infected needle with HIV, and he injected it into his arm. He wanted to prove that he will not die of AIDS, and he actually did, since he died from a heart attack a year later. So the main argument between the whole HIV doesn't cause AIDS thing is that they claim that it's more about the lifestyle choices. So if you're a drug user, you have some other issues which give you this weird form of disease which we call AIDS. But the thing is that not all the people who, for example, do drugs develop AIDS, but all AIDS patients have been infected with HIV. And in this pool we find newborns who have been infected during pregnancy, but the mother didn't take any drugs. And then there's also the unfortunate accident where 3 scientists were infected with HIV in the laboratory. They didn't take any drugs or anything, and they died of AIDS a couple of years later. Number 3, the HIV medication do more bad than good. And I mean, yeah, the HIV medication is a form of medication, a quite potent one, since HIV is also a nasty virus, meaning that you can have some side effects. But current HIV medications are very, very good in keeping the number of HIV particles in your blood low and keeping your immune system intact. And the whole alternative to not taking your HIV drugs is that you slowly, over the years, and it might be 10, 15 or 20 years, develop AIDS and die. So overall, taking HIV medications is the best thing someone with HIV can do.